In October 2017, something unprecedented occurred. Astronomers scanning the sky with a powerful telescope atop a volcano in Hawaii spotted a small, fast-moving object. It was speeding through the solar system at a velocity never seen in any asteroid or comet of local origin. This wasn't just another space rock. This was the first confirmed visitor from another star. Its name? Oumuamua. The object was discovered on October 19, 2017, by astronomers using the Pan-STARRS 1 telescope, part of a sky survey program dedicated to spotting near-Earth objects. Located on the summit of Haleakala, a dormant volcano on the Hawaiian island of Maui, Pan-STARRS had been scanning the skies for years. But on that day, it caught something extraordinary. Initially cataloged as a comet and designated C 2017 U1, it was later reclassified as an asteroid. And then, realizing it originated from beyond the solar system, astronomers renamed it 1I/Oumuamua. The 1I indicates it was the first known interstellar object, and Oumuamua is a Hawaiian word roughly translating to a scout sent from the distant past. It was unlike anything previously observed. It had a hyperbolic trajectory, which means it wasn't orbiting the sun like other objects, but instead passing through the solar system from interstellar space. The sheer speed and angle of its approach confirmed its alien origin. Immediately after the discovery, scientists raced to study this rare visitor. They quickly noticed some perplexing characteristics. Oumuamua was not behaving like a typical asteroid or comet. It showed no visible coma, no tail, the usual signs of ice vaporizing from a comet when it gets close to the sun. The light curve, a graph of its brightness over time, revealed that it varied dramatically as it tumbled through space. This suggested an extremely elongated or flattened shape, unlike any known object. Some scientists estimated it could be up to 10 times longer than it was wide, like a cigar or a pancake. Its rotation was also odd. Oumuamua didn't spin on a single axis like most objects. Instead, it tumbled chaotically, indicating it had been through some dramatic events in the past, perhaps ejected violently from its home system. The biggest surprise came when it passed closest to the sun. As it began to move away, it sped up, slightly but detectably. This acceleration didn't match predictions based solely on gravity, and without visible gas emission, there was no apparent source of thrust. Faced with these puzzling facts, scientists proposed several theories to explain Oumuamua's behavior. One idea suggested it could be a type of comet made mostly of hydrogen ice. As the hydrogen sublimated into gas, it could produce thrust too faint to be detected. But hydrogen ice is extremely volatile and unlikely to survive long interstellar journeys. Another theory posited it was a fragment from a larger body, perhaps torn apart during a close encounter with a star. This would explain its odd shape and tumbling motion. Some researchers considered it a new type of asteroid made from unusually reflective or light materials. But none of these ideas could explain the observed acceleration without some sort of outgassing or propulsion. Enter one of the most controversial theories. Avi Loeb, an astrophysicist at Harvard University, made headlines when he proposed that Oumuamua might be artificial, a probe or debris from an alien civilization. According to Loeb, the acceleration could be explained if the object was being pushed by radiation pressure from sunlight, much like a solar sail, a concept already being developed by space agencies on Earth. He pointed out that the object's thin, flat shape would be ideal for this kind of propulsion. Loeb's argument wasn't that it had to be alien, but that the artificial origin should be considered as seriously as natural explanations. He published his case in the book Extraterrestrial and in several academic papers. His ideas were met with both curiosity and criticism. Many scientists argued that invoking aliens was premature without more evidence. But Loeb stood firm. If an object behaves strangely and defies known explanations, we shouldn't ignore the possibility just because it makes us uncomfortable. Unfortunately, Oumuamua was already leaving the solar system by the time its significance was recognized. Discovered after its closest approach to Earth, scientists had only a few weeks to gather data before it faded from view. No telescope could resolve its shape. No spacecraft could catch it. Its closest approach to Earth had been about 24 million kilometers, relatively close, but not close enough for detailed imaging. And its speed, over 87 kilometers per second, made it impossible to intercept with current space technology. All we have are a few measurements of light and motion, enough to know that it's strange, not enough to say exactly what it was. Oumuamua's brief visit was a wake-up call. It showed us how ill-equipped we are to study fast-moving interstellar visitors. By the time we spotted it, it was already on its way out. Astronomers are now advocating for rapid response capabilities, telescopes that can identify and alert scientists in real time. Some even propose building spacecraft ready to launch on short notice, or pre-positioned in space to chase down the next interstellar traveler. We've also started rethinking what we consider normal in space. Oumuamua taught us that the universe can still surprise us. In 2019, a second interstellar object entered the solar system. This time it was caught much earlier. Named 2I/Borisov after the amateur astronomer who discovered it, this object looked and behaved like a typical comet. It had a tail. It released gases. It was in many ways the opposite of Oumuamua, and yet it came from the same cosmic sea. This contrast only deepened the mystery. Why was Oumuamua so strange? Why did it accelerate without jets of gas? Maybe Oumuamua is rare, or maybe we just don't have enough data. After all, we've only seen 2 interstellar objects so far. Thanks to advances in telescope technology, more visitors like Oumuamua are likely to be detected in the coming years. The Vera C. Rubin Observatory, scheduled to come online soon, will scan the entire night sky every few nights, vastly increasing our chances of spotting these fast-moving interstellar travelers. And with better data, we may finally learn what these objects are made of, where they come from, and maybe even who sent them, if anyone did. The next object might come closer. We might intercept it. We might get answers. The story of Oumuamua is not just about a strange rock hurtling through space. It's about humanity standing at the threshold of the unknown. It reminds us that the universe is still full of surprises, that our solar system is not an isolated island. Perhaps Oumuamua was a shard of alien geology, or a technological relic, or something even stranger. We may never know. But its brief visit changed our view of the cosmos. The sky is full of wonders. Some, like Oumuamua, pass quickly, like whispers on the wind. Others are yet to come, and when they do, we'll be watching. Until then, we search, we learn, and we wonder. If you enjoyed this video and want to see more like it, please consider giving this video a thumbs up and subscribing to the channel. Thanks for watching.